So now let's start with the first question. This is a question based on limits. So what has been given to us? Limit x tending to 0, e minus 1 plus 2x to the power 1 by 2x upon x. So if I do direct substitution, what am I getting? I'm getting 1 to the power infinity in my numerator and 0 at my denominator. So of course, this is not any type of indeterminate form. It is a mixture of two indeterminate forms. So let us try to solve this in some other way. What are the other ways that we can think of? Since this is not a 0 by 0 or infinity by infinity, we cannot use the LH rule as well. So what are the other ways that we can solve it? We can do this by expansion. Of course, I hope you all remember the Maclaurin series, where f of x could have been written as f dash 0 plus f dash 0 x plus f dash 0, and this continues. So similarly, what is the function that we are going to open up here? It is going to be 1 plus 2x to the power 1 by 2x. So if I try to open up this equation using the Maclaurin series, what am I going to get? This is going to become e. So basically, to differentiate this entire term, I hope you all remember how we can differentiate this. It can be differentiated using the chain rule or by simply taking ln on both sides. If you take ln on both sides, this power would come below, and based on that you can differentiate this. This would become minus 2 into e into x by 2 plus, here you would have 11 into e into 4x square upon 24, and this would continue on forever because we only need up till x square term, because rest all the terms would become 0 as we divided by x. So here now I can write this down as limit x tending to 0. I can simply take e common from all these equations. What am I going to be left with? E into e minus 1 minus 2x by 2 plus 11 into 4x or 44x. Let me write this down as 44x square by 24 minus, and this would continue on forever, and we have an x below. So from here what I can see is that I can simply cut out x from each and every variable, and what am I going to be left out with? Here if you look at this carefully, this one and this e would cancel out because this is a multiply with e, and simply I can cancel out x from all the other variables, and what am I going to be left with? Simply e. All these other terms would have x in them, and as I put x is equal to 0, all those terms would also become 0. So my answer would simply become e. So this is how you solve questions. Of course, whenever you do not find any other way to solve the question, use the Maclaurin series or the expansion methods that we have studied. Let's look at another question. What they've told us for a and b, again a and b are the unknown variables in the functions that have been given to us, and they've told us that this function is continuous at x equals to 0. Then what is my b by a? So basically what do I have to find out? My f of 0 would be equal to my f of 0 minus would be equal to my f of 0 plus. So if this equation is satisfied, that means I can say my function is continuous. What is my f of 0? It is simply 3. Now let us find out my f of 0 minus. It is going to be this function, right? So limit x tending to 0 minus, this would be tan of a plus 1 x plus b tan x. Let me take the x separately, separate out these two terms. Now here what I can do is I can simply multiply a plus 1 on top. Here I can multiply b and another b on top. Sorry, b is not required here because already it's tan x by x. So since x is tending to 0, what does this limit turn out to be? It becomes 1. So my answer would basically be a plus 1 plus b. Now I can say this should be equal to 3. So from here a plus b should be equal to 2. So this is my first equation that I've gotten. Now let me solve for the other equation. What is my other equation going to become? It is going to be limit x tending to 0 plus. So what is the equation that has been given to us? root under ax plus b square x square minus root under ax upon b root under a into x root x. From the above equation, what I can do is I can take root x to be common. So if I take root x to be common, this would become limit x tending to 0 plus root x comes out common. Here I would be left with root under a plus b square x minus root a upon b root a x root x. So root x and root x would get cancelled out, and here I have x, and on top I have a root minus a root. So what I can do is I can simply use my method of rationalization to solve this question further. Now if I use rationalization, what would this equation become? Limit x tending to 0 plus, this would be root under a plus b square x minus root a, this divided by b root a into x. Now what I can do is I can rationalize this by multiplying it with its conjugate, a plus b square x plus root a divided by root under a plus b square x plus root a. Now let me multiply this and put the value of x to be 0, or maybe after multiplying this I have to eliminate this x, then only I can put x to be 0. So till then let's keep it as it is. So from here what are we going to get? This would become a plus b square x minus a square, sorry, minus a. From here a and a would get cancelled out, and we would be left with b root a x into root under a plus b square x plus root a. So from here x and x would also get cancelled out, b and b would also get cancelled out, and what are we going to be left with? B by, if I put x to be 0, this would become 2 root a, so this would be 2a. This value also we know this is equals to 3, so b would be equal to 6a, and we know that a plus b is equals to 2. However, what was asked to us in the question, we had to find out b by a. So simply we can find out b by a to be 6. We did not have to use this equation, of course. Had they asked us to find out the separate values of b and a, then we could have used this first equation, a plus b is equals to 2, and then found out our answer. However, we only had to find out b by a, so simply 6, this becomes our answer. So this is how you solve questions. You try to identify what type of solving limit do I have to use, whether it is rationalization, factorization, LH rule, or any other expansion or Maclaurin series. Let's look at another question. Limit n tends to infinity. Okay, so an equation is given here. So of course we have to solve this separately, right? Now n is tending to infinity. So I hope you all can remember the thing that we had studied about m and n, where the powers of infinity, the highest power at the numerator and denominator, if they become equal, that means we can say that their coefficient would only become our answer. Else, if our power in the denominator is greater, then it would become 0. If our power in numerator is greater, then it would become infinity, or the limit wouldn't be defined. So here let us first find out what is the highest power in the numerator and the highest power in the denominator. So for numerator, let us first solve for numerator. So if you look at this equation carefully, if you look at the final equation here, what is the equation that we are having here? This would become n whole square, and we have a minus along with n minus 1. So if I was to write down the rth term of this equation, rth term, so how can I write down my rth term? It would become simply r square minus r, this multiplied by n minus r, and here my r varies from 1 up till n minus 1, because my r is n minus 1, right, in the final equation here. So this is what I have. Now let me simply multiply this and use my sequence and series theorem to find out my answer. So how can I write this down? This equation would simply transform to summation r is equals to 1 up till n minus 1. This would become r square n minus rn minus r cube, and this would become plus r square. So r square can be taken common. So we would have simply summation n plus 1 into r square plus summation of, sorry, this would become minus summation of minus n into r minus summation of r cube. So now simply what I can do is I can use my sequence and series formulas. What used to be my sum of squares of n natural terms. My sum of n natural terms used to be, so I can take this constant term outside. Since I have an r square here, this would become n into, sorry, this, since we have r from 1 to n minus 1. So first of all, my summation r square for r is equals to 1 to n. What does this used to be equal to? This used to be n into n plus 1 into 2n plus 1 upon 6. Now since it is up till n minus 1, so what if I substitute n minus 1 here? This would become n minus 1 into n into 2n minus 2. So this would become 2n minus 1 upon 6. So I can simply write this down here. N into n minus 1 into 2n minus 1 upon 6. What would be my term here? Sum of n natural numbers, n into n plus 1. So this would become n minus 1 into n upon 2 minus, here I would have n into n minus 1 by 2 whole square. I hope you are understanding why I am writing n minus 1, because my sum used to be from r is equals to 1 till n. However, here we have terms from 1 to n minus 1. So you have to substitute n as n minus 1 in the equation. Then you would get this answer. So this is the equation that we've gotten. Now what was the exact value that we were trying to find out? We were trying to find out the highest power. So if you look at these three terms carefully, what is the highest power? From here, what is the value that you can get? Here you would have an n square, and squaring that, I would have an n to the power 4 here. Here I have an n cube, and here again I have an n to the power 4. So basically, what is my highest power here? So my highest power is basically n to the power 4. Now I have let me find out the coefficient as well, because what will happen is, if I find out my highest power in the denominator as well, and if it comes out to be n to the power 4, simply my coefficient of numerator divided by my coefficient of denominator would become my answer. So let me find out its coefficient. From here, what am I going to have its coefficient? Simply it would be n square n. So I would have 1 by 6, 1 by 3 here, and I would have 1 by 2 or 1 by 4 from here. So if I see from here, what would be my coefficient? I would have a 2 by 6 here. From here my coefficient would be 1 by 4, and I have to subtract 1 by 3 from 1 by 4. So basically, if I subtract 1 by 3 from 1 by 4, what is it going to be? LCM would be 12. Here I would have 4 minus 1, so 1 by 12. So my coefficient is 1 by 12. Now let me solve for denominator. This was up till numerator. Now let me solve for denominator. What is my rth term in the denominator? How can I write down my rth term? So it can simply be written as r cube, where r is equal to 1 up till n, minus summation of r square. So here again I have r from 1 up till n, so I can simply use my formulas that I have. I do not have to replace n with any other variables. So from here, what am I going to get? This would become n into n plus 1 upon 2 whole square, minus this would become n into n plus 1 into 2n plus 1 by 6. So from here also, what I can see is that my highest power is n to the power 4. My highest power is n to the power 4. So, and what is my coefficient of this highest power here? In this term, I do not have any highest power. This term, it is going to be 1 by 4. So I can see that my highest power is same in the numerator as well as denominator, and I have n is tending to infinity. That means what would be my answer? Simply the coefficient of numerator of the highest power divided by the coefficient of denominator of the highest power. So my answer would simply become 1 by 12 divided by 1 by 4. Or simply I could have written this down as n to the power 4, n to the power 4. This would simply cancel out amongst each other. And what do I have left out as my answer? 1 by 3. This is my answer. So this is how you must solve questions. Whenever you see limit n tending to infinity, try to find out the powers of both numerator and denominator, highest powers. And if they come out to be equal, then the coefficient simply becomes your answer. Now let's look at this question. What has been given to us? Let f of x is equals to, they've given us a polynomial equation in which we have x as mod x. So basically f of x, they've tried to represent this in this format, modulus x square plus 5 of mod x minus 3, because modulus x square is of course going to be x square only, it does not matter. So if m and n denote the number of points where f is not continuous and not differentiable, then m plus n is equal to. Now for questions in which you have been given a polynomial, so first of all you can understand that polynomial is continuous at each and every point. However, since they've tried to twist it in some format, they've given us mod x, so we will have to check for the continuability in each and every point as well as the differentiability. So what is the simplest and the most easiest way? We simply draw the graph of this entire function. Since it is a polynomial, so I hope you all understand that it is going to be in, let's say, a parabolic shape. We have a greater than 0, so it is going to be in a parabolic shape, upward parabola, right? Now this upward parabola, since we are using modulus x and we are taking the modulus of the complete equation as well, so if let's say this is my x-axis, so this function would simply transform into this way, because there would be no function below, right? So it would transform this way. So let us try to draw the graph and see what are the values or what type of graph are we attaining from this. So first of all, it is necessary you draw the x and y axis. Now find out what is the value at x is equals to 0. If I put x is equals to 0, I am getting the value to be 3. Of course, minus 3 would be transformed into 3, right? Now, what are the values at which I would get x is equals to, my y to be 0. So if I put my y to be 0, I would have the equation in this format, 2x square plus 5x minus 3 is equals to 0. Here I have a modulus x. I must remember this thing. So for the time being, what I'm saying is, let me take my modulus x to be, let's say, another variable, which is, let me take it to be a. So what do I have? 2a square plus 5a minus 3 is equals to 0. So from here, what are the factors of this equation that I'm going to get? A would be equal to minus b plus minus root under b square, which is 5 5s are 25, minus 4ac, 4 3s are 12, 12 2s are 24 upon 2a. So this basically transforms into 49, which becomes 7. So from here we would have minus 5 plus minus 7 by 4. So what are the values of a that we are getting? One of them is going to be 1 by 2 and the other one is going to be minus 12 by 4, which makes it minus 3. And this a here, this we know it is a modulus x. So what is this going to be? Modulus x is half and modulus x is minus 3. So of course we know from here that modulus x can never be minus 3. Modulus x is always going to give us a positive value, right? So we cannot take this value. That means modulus x is half. That means from here what can we say? X is equals to plus minus half. That means that plus minus half, our graph gives us the value y is equals to 0. That means I can say here I have my plus half, here I have my minus half. So that means I've gotten my basically equation. So from here it is going to be increasing in this format, and here since it is the entire modulus, had there been no modulus here of in f of x, let's say if this modulus wouldn't have been given to us, then our 3 would have been minus 3 and this would simply become a complete parabola. Now since there is a modulus as well here, so anything under the x-axis would be taken upwards. So simply that is what happens here. The graph becomes this way. Now from this graph, you can see that this graph is continuous at all points. From minus infinity to plus infinity, this graph is going to be continuous. And m is the value that denotes the number of points of continuity. So m would become 0. N, the points at which it is not differentiable. From the graphical representation, I hope you all remember, wherever we have a sharp turn or points at which dy by dx or the slope cannot be found out, that points become our non-differentiable points. So here you can see 3 is one of them, half is one of them, and minus half is one of them. Here we have a sharp turn. It is not a smooth curve, it is a sharp turn. That is why we cannot have differentiation at these 3 points. Apart from that, each and everywhere our graph can be differentiated. So my n, the points at which our graph is not differentiable, becomes 3. And we had to find out m plus n. So my m plus n simply becomes 3. And this is my answer. So this is how you solve questions. Sometimes you might have to draw the graphs as well. Based on the graphical representation, you can solve your question very easily. Let's look at the next question. What has been given to us here? F of x has been given 3 functions, 0 and 1. That means there are 2 points at which we have to check our continuity first of all and differentiability, which is 0 and 1. If f is continuous everywhere in R and m is the number of points where f is not differentiable, then m plus a plus b plus c is. So first of all, they've told us that f is continuous everywhere. That means it is going to be continuous at 0 as well as at 1. So let us check and find out the value of a, b and c, whether it is what are the values of a, b, c we are getting based on the information that this function is continuous everywhere. So first let us check for 1. So what are we getting the value of f of 1 to be? F of 1 would be simply c plus 2. F of 1 plus, what would this value become? This would become 3. And f of 1 minus, this would also be c plus 2. So since these are this is a continuous function, so c plus 2 would be equal to 3. Sorry, here we would have a 1 as well. This would be a plus 1. So c plus 2 plus 1, this should be equal to 3. That means c is equals to 0. So we've gotten our first value from the first equation. Now let us check for the other point as well, for 0 as well. For 0, what can we say? F of 0 should be equal, what would it be equal to? 0, 0. F of 0 is 2. F of 0 plus, this would also become 2. And f of 0 minus. Now let us calculate this. This is what has been given to us, a minus b cos 2x by x square. So here we have limit x tending to 0 minus. Now let us try to find out the value of this. From here what we can see is this value, first of all we know this should be equal to 2, of course, as per our equations that we are trying to solve. Now what we can see from this equation is that had this a and b been 1, so what would have it had become? 1 minus cos 2x by x square. And what is that value equal to? It is equal to half into 2 square, because of course we have to make this x square as 4x square, right? So I would multiply 4 below and 4 above, so I would get a 4 outside as the answer, right? Or what is the other thing that can happen? Either a and b becomes equal. So in either case, a and b has to be equal. So assuming a and b are equal, I'm assuming it to be a. So what would we get from here? This would become limit x tending to 0 minus, we would have a taken out as common, 1 minus cos 2x upon, here I would have x square, which I've made it as 4x square, and I've multiplied a 4 here. So this entire term, what does this value become? This becomes half. This is equals to 2. So from here what do we get? 2a is equals to 2. So from here we get a is equals to 1. That means this value is only equal to b. That means the assumption that we had taken is correct, which is a is equals to b. And of course, by the look of it, you can see that if I take b common from this entire equation, or a common, I would simply try to get, I would simply get my answer, which is 2. So we found out our 3 values, a, b and c. Now what have they told us? M is the number of points where it is not differentiable. So first of all, let us write down our equation in a better way after putting the values of a, b and c. What do we get? This becomes 1 minus cos 2x by x square for x less than 0. We would have x square, c is 0, so this would be just plus 2 for x less than equal to 1 greater than equal to 0, and 2x plus 1 for x greater than 1. Now since we have to find out, check its differentiability, so what are we going to do? We are going to find out our f dash x. So what is my f dash x going to be for the first? Let me differentiate this entire thing. What am I going to get? Let me do it here. 1 minus cos 2x by x square. I will have to use the quotient theorem. So differentiation of first, this would make it sine 2x, 2 times of second as it is, minus differentiation of second and first as it is, by, and this becomes to the power squared, so this becomes x to the power 4. So from here we can simply cancel out 1x, this would become 3. So what do we have? We can take 2 common, so we are left with sine 2x. This would become plus 1, sorry, this would remain minus 1. This would become plus cos 2x, and here we have x cube. So simply we can put this value here, so this would become 2 times of sine 2x plus cos 2x minus 1 upon x cube. Here what are we going to get? We are going to have 2x, this would simply be 2. X is greater than 1, x is less than equal to 1, greater than equal to 0, and here we would have x less than 0. Now let us try to solve this. Now let us check for the differentiability of this point. So here what do we have? First of all, we have to check at 1. Of course, it is the point where function is changing. So at 1, we are getting f dash 1 to be equal to 1 for both the functions. So it is differentiable at 1. So 1 is not our point of discussion now. Now let's check for 0. For 0, f dash 0 plus, what is this we are getting? We are getting this to be 0. That means f dash of 0 minus should also be 0. If it is 0, that means we can say that this is differentiable at each and every point. So what do we have to find out? Basically we have to find out limit x tending to 0. 2. Let me now separate each and every function from each other. So this would become 2 times of sine 2x by x cube. Here I would have cos 2x by x cube. Sorry, there is an x also multiplied here. So this would become x minus 1 by x cube. So from here what I can see is x and this would become square. This gets cancelled out. So from here what do I get? This entire function to be, I have to multiply a 2 here and a 2 on top as well. So this thing would become 1 and I would have been left with 2 by x. So this becomes 2 by x plus. Now what I can do is I can take minus common from this term. If I take minus common, this would become 1 minus cos 2x by x cube, or what can I write it down as 4x square and take 1x out and multiply 4 on top. So 4 would get multiplied here and 1x would be left out as it is, and here I would have 1 by 2 simply. Now if I look at this entire equation, this thing is multiplied by 2. From here what am I going to get? This would become 2 times. So this and this term simply gets cancelled out. So what are we left with? 0. That means now here in this question, most of you, what you would have done is you would have simply seen that there is an x below, and of course it is not going to be differentiated at x is equals to 0. Then you would have said that the limit does not exist, right? However, if you try to calculate it till the end, what you can see is it is becoming 2 by x minus 2 by x, both of which gets cancelled out, and we get 0 as our answer. That means it is differentiable at x is equals to 0 as well. That means there are no such points in which it is not differentiable. That means I can say my m is also equals to 0. Now what had they asked to us in the question? We had to find out m plus a plus b plus c. So we simply m plus a plus b plus c, this comes out to be 2, and this is our answer. So this is how you must solve. Of course, this point here, this differentiation point, was the difficult part, I would say here, because most of the times what would happen is people would see that there is an x in the denominator and simply they would say that limit does not exist. It would come out to be infinity. However, if you try to solve this question till the end, you can see that we get a 2 by x minus a 2 by x in both the cases. So in both the terms, so these two terms would simply cancel out each other and our answer would come out to be 0. Let's look at another question. If limit this is 1 by 3, so simply we have to find out the value of alpha and beta. So a very easy question. You can see we have sin x, cos x, log ln 1 by 1 minus x on top. So what we can do is we can simply expand these three equations and then look out for our answer. So as soon as you get this, what you can see is tan square x is here. So simply I divide this by x square and I multiply an x square here. So this term here, this would become 1. And now I would have to eliminate x square based on these three equations and their x terms. So let me try and expand this. So what would this become? This would be 3 plus alpha times of, how do we open sin x? Sin x opens up as x minus x cube by 3 factorial. I'm just going to do for two terms because I know x square is going to cancel x cube twice and rest of the other terms are going to be 0. So simply I'm going to just let it be till here, plus beta times of cos x. Cos x, how does it open up as 1 minus x square by 2 factorial, and then I would have x to the power 4 by 4 factorial. Again x to the power 4, it can be cancelled out by x square twice. Still I would be left with x square in the numerator, so it would become 0. So I'm leaving it up till here. Or for this one also, since x cube is not necessary, I'm simply just removing it. And here, log of 1 minus x. How do we open log of 1 minus x? Simply we can open up 1 plus x, and instead of x, I'm using minus of x. So this would open up as minus x square by 2 and minus x cube by 3, and this would go on. So I'm still just taking two terms, and below what do we have? 3x square. So now from here what we can see is, first of all, we have to eliminate all the neutral terms as well as all the single power terms. So what we can see is, what are the terms which are constant? They have to be 0, and the terms which have x to the power 1, all those coefficients also have to be 0. Then only we can simply cancel out x square and then get our answer, right? The coefficient of x square would become our answer. So that is why what we are saying is 3 plus beta, this should be equal to 0. So from here what do we get? Our beta is equals to minus 3. So we've gotten our first value. Another thing, for alpha also each and everything has to be 0. Sorry, for x. So here we have alpha, and what are the coefficients? Minus 1. This also should be equal to 0. So from here we get alpha is equals to 1. And now if you look at this entire equation, what does this equation transform into? It would simply become minus beta x square by 2 factorial minus x square by 2 upon, I would have 3x square. So from here what we can see is x square would cancel out all x square, and this value would be equal to 1 by 3. If I was to check my answer, this would be 2, and again I would get my beta to be equal to 3, minus 3. That means the values that we have chosen are correct. So 2 alpha minus beta, we found out our alpha, we found out our beta, so this would become 2 plus 3, which makes it 5. This is our answer. So this is how expansion questions are solved. Let's look at next question. If a is equal to this and b is equal to this, then what is the value of ab cube? So simply let us solve both the limits separately. So let us first solve for a. Limit x tending to 0. By the look of this limit, what you can see is there is an irrational term in the numerator, so let's rationalize it. So this would become root under 1 plus root under 1 plus x to the power 4 minus root 2 upon x to the power 4. What I do is I multiply 1 plus root under 1 plus x to the power 4, this whole is under root, plus root 2 upon, I divide it with the same thing, plus root 2. Now upon rationalization, what are we getting? Limit x tending to 0. This would become 1 plus root under 1 plus x to the power 4 minus 2 upon x to the power 4 into root 2 plus root under 1 plus root under 1 plus x square. Now if you look at this equation on top, what does this transform into? Basically this is, I'm directly writing down minus 2 and plus 1 would make it minus 1. Now if I look at this, again I can rationalize this equation. If I rationalize this now, I have to multiply 1 plus x to the power 4 plus 1 upon root under 1 plus x to the power 4 plus 1. So upon now multiplying this, what do we get? X tends to 0. Here I would have 1 plus x to the power 4 minus 1. 1 and 1 would get cancelled out. I would have x to the power 4. Below I have x to the power 4 root 2 plus root under 1 plus x square into 1 plus root under 1 plus x to the power 4. Sorry, this is not square here. This is to the power 4. So x to the power 4 simply gets cancelled out, and if I put x is equals to 0 in this equation, what do we get? A value to be 1 by 4 root 2. So you can see root 2 plus here we would have another root 2, and upon multiplying this with 1 plus root 2 we are going to get 4 by root 2 as our answer. So we found out our value of A. Now let us find out our B. Let us solve for B. What do we have in the question? Limit x tends to 0 sine square x upon root 2 minus root under 1 plus cos x. Again you can see that there is an irrational term in the denominator. So let us rationalize this by multiplying root 2 plus root under 1 plus cos x, and on top also root 2 plus root under 1 plus cos x. So what do we get? Now since each and every term here you can see is in terms of cos x, so what I'll do is I'll also convert this sine square x into cos square x. It would become 1 minus cos square x, right? So that I have all the terms in terms of cos, and then I'll see what are the things that are getting cancelled out or what are the things that I can take common. So from here what I will say is limit x tending to 0, this is 1 minus cos square x into root 2 plus root under 1 plus cos x upon this term would become 2 minus 1, so this would become 1 minus cos x. Now if you look at this entire equation carefully, 1 minus cos square x, how can you write this down? It can be written as 1 minus cos x into 1 plus cos x. 1 minus cos x and 1 minus cos x would get cancelled out. So what are we left with now? This would simply become 1 plus cos x into root 2 plus root under 1 plus cos x. Now from here, if I put x value to be 0, if I put x is equals to 0, what am I getting? 4 root 2. This becomes 2, this becomes yes. So this is 4 root 2. So my B value comes out to be 4 root 2. And what was asked to us in the question? We had to find out AB cube. So if we have to find out AB cube, how can we find it out? It would be 1 by 4 root 2 into 4 root 2 into 4 root 2 into 4 root 2. This and this gets cancelled out, so we get our answer to be 32. So this is how questions of limits are solved. Try to convert all types of trigonometric equations into one type of equation, so that, like how we did here, we could see that 1 minus cos square x, we could have converted it into 1 plus cos x into 1 minus cos x, and then of course it would cancel out each other. For other questions as well, try to convert your entire limit into one type of trigonometric function, so that you can see from where you can take out things common and from what are the things that you can cancel out. So that was all for this chapter. Again, I would say this is quite the basics of calculus, so it is important that you understand each and every concept in this chapter, how limits work, how differentiation work, their proofs, continuity, because based on this we are going to be studying the further chapters of calculus, which is our application of derivatives, our integration, our differential equation. So an important chapter. I would recommend you to revise all the concepts regularly and the expansion series and the Maclaurin series. That's all. Thank you.